Okay, last time I showed you guys how to differentiate square root of x plus square root of x plus dot dot dot. This time I'll show you guys how to integrate this guy. So first, let me just do a quick review with you guys. I will begin by saying that y equal to this. We have infinitely many square root of x plus square root of x plus square root of x plus dot dot dot. Okay? Well, if we have y is equal to this, now let me write it down in black. We pretty much have y equal this integrand. Once again, it's the square root of x plus square root of x plus square root of x and so on. But for this part right here, let me write it down in red. So we will have this square root of x plus square root of x plus dot dot dot. If you look at the red part, we actually have the y in red. Yes, we have a y inside of a y. So in here, we will have y equal square root of x plus all this in black, but then the rest, we can put down a y right here. So the connection is y is equal to square root of x plus y. And if I can somehow isolate the y from this equation in terms of just x, then we can find the closed form of this crazy expression. And let's do that. To do so, of course, let's square both sides. So we will have y squared equal x plus y. And this is pretty much quadratic in y, right? So we can just subtract y on both sides. We get y squared minus y. And let me leave a space right here for good reason, you'll see. Equal to x. And now, why did I want to leave a space? Because I want to complete the square on the left-hand side. Because this is just y squared minus y, right? And this is how we complete the square. First of all, make sure that we have a 1 in front of the y squared, which we do. Now, to do this, we take 1/2 of the coefficient of the y, in this case, which is -1. So we multiply by -1, and then we square that. This is pretty much the formula. So we'll see, inside here is -1/2, and when we square that, this is going to give us 1/4. And this is a number that we have to add on both sides. And it's guaranteed that the left-hand side will be a perfect square. And when you factor this, this is y minus, okay, you can look at this as a minus. Another thing is you can look at this. That's why I showed you guys all the work. Minus 1/2 square. We can just factor it, up to you, but this is always this number. Anyway, y minus 1/2 and then square, this is equal to x plus 1/4. But let's do some fraction business, okay? Because I have to take the square root on both sides later, so let's do some fraction business. Let's add this. So here we have x plus 1/4. Let me multiply this by 4 on the bottom and also 4 on the top. So in other words, altogether here, we have 4 and then 4x plus 1 on the top, like this. And now, I will have to take a square root on both sides. And usually, when we take square root on both sides, we put down plus minus, isn't it? Well, this is pretty much the deal. We cancel this out. But on the left-hand side, we have y minus 1/2. That's equal to plus minus this. Okay, let's just leave it here because I'm not sure if I have to take both the plus or minus. Let me just leave it here because we still have the -1/2 for the moment. So let's be patient a little bit, and I will have to write it here. Anyway, here we have y equal. This is y minus 1/2. We bring the 1/2 to the other side, so we have a positive 1/2, okay? And then here, as I said, I'm not exactly sure if I have to put down plus minus, which one, right? So let me just keep it for now, plus minus. We can do the square root of 4 on the denominator, which is going to give us 2. And then on the top, we just have square root of 4x plus 1, okay? So in another word, this is exactly what y should be. And now, shall we do the plus or shall we do the minus? Well, you know that this guy, square root of whatever inside, this is always positive, so let me just put down greater than 0. Here, this is also y. right? So we should also make sure that this is always positive because they are pretty much the same thing. They just look differently. Okay, so the reason that I have to get rid of the negative, it's because if x is a big enough number, such as, let's say, if x is equal to 6. If x is equal to 6, here we have 4 times 6, which is 24, plus 1, which is 25. Instead of that, which is square root of 25, we get 5. You're talking about 1 over 2 minus 5 over 2. You end up with a negative result. That's not good, all right? So you just want to talk about the plus version for that. Anyway, here we have this expression that's equal to y, and y is, of course, our original integrand. So, put things together, we are saying that the square root of x plus the square root of x plus the square root of x plus dot dot dot, this is equal to 1/2 plus square root of 4x plus 1 over 2. And of course, both of them have the 1/2. Let's factor it out to the front. So let me put that down first, and then the parentheses, and then we will have 1 plus the square root of 4x plus 1, like this. And of course, originally, we wanted to integrate this guy, so we'll do it, of course. And that's the same as integrate this guy. But we see that we have a 1/2, that's a constant multiple of this part. So let me just put the integration sign right here. In other words, I took out the 1/2 as a constant multiple to the front of the integration. And then, of course, we have the dx right here. Okay, now, we just have to integrate this part, right? Let's first put down the 1/2 and then open the parentheses for the result of the integration. To integrate 1 in the x world, we get x. How can we integrate this? In fact, we're pretty lucky because the inner function is just 4x plus 1. The derivative of this is just a 4, right? So we can do the u substitution in our head, that kind of thing. And of course, let's write the square root as to the 1/2 power. And you can look at this as a u to the 1/2 power. And to integrate that, you of course add 1 to the power first. So let me put it down in blue. You add 1 to the power, and you get 3/2 divided by this power, which you get 2 over 3, right? So I'm going to put down plus. We have the 2 over 3 right here. And the inner function part stays the same. So let me just write it down. 4x plus 1. And then that's raised to the 3/2 power now. And then, you know, to do the integration, you have to divide it by the derivative right here. It's just a constant. The derivative of 4x plus 1 is 4. Divided by 4, it's the same as multiplied by 1 over 4. And we are done with all that. And now, to finish things up nicely, I'll put on plus c all the way at the end. All right, so I haven't put on the plus c yet. Anyway, just distribute. Right here, we get 1/2 x. 1/2 times 2 over 3, the 2 cancel. So we can just look at this as 1 over 4 times 3. In other words, plus 1 over 12. And then the function part is this. Depends on if you like exponents more or radical more. And because we have originally we have a lot of radicals, we should keep having radicals, right? So write down the 1/2 power as a radical, that's square root, and then write this down as 4x plus 1 to the 3rd power, and we're done. Okay? So this is how you integrate that. Anyway, that's it.
So good.